Let us verify Rolle's theorem for the function fx equal to sin x plus cos x in the interval 0, pi by 2. So if we want to verify Rolle's theorem, we need to make sure three criteria are satisfied. First one is f has to be continuous. Must be continuous. You see that it is obviously continuous function. We can say that f is continuous in closed interval 0, pi by 2. What about differentiable? It's also obvious that it's differentiable. F is differentiable. F is differentiable. We don't need it to be on the whole of closed interval. We just need on the open interval 0, pi by 2. In fact, we can simply differentiate it. We know that derivative of sine is cos and derivative of cos is minus sine. Last point, we need to show that f of 0 equal to f of pi by 2. The value of the function at the end point 0 and pi by 2 at the end point value of function are equal. F of 0 equal to sine 0 plus cos 0. Sine 0 is 0, cos 0 is 1. What about f of pi by 2? F of pi by 2 equal to sine pi by 2 plus cos pi by 2. Sine 90 degrees 1, cos 90 degrees 0. So we find that f of 0 equal to f of pi by 2. The value of the function at the end point are equal. So all the three criteria are satisfied. F is continuous on the closed interval, f is differentiable on the open interval, and the value of the function at the end point are equal. Once those three criteria are satisfied, we can say that Rolle's theorem is applicable. So all the three criteria are satisfied and Rolle's theorem is applicable. Now once the Rolle's theorem is applicable, Rolle's theorem guarantees existence of constant c in the open interval such that f dash c equal to 0. Now, if Rolle's theorem guarantees existence of such a constant, we should be able to find such a constant. F dash x equal to d dx of fx and fx equal to sin x plus cos x. Fx equal to sin x plus cos x. How much is derivative of sin x? Yes, cos x. How much is derivative of cos x? That's minus sin x. So f dash of c equal to cos of c minus sin of c. Rolle's theorem guarantees us existence of a constant in the interval 0, pi by 2, both excluded. We should be able to find such a constant. F dash c equal to 0. Let's try to find if cos of c minus sin of c equal to 0, that is sin of c equal to cos of c. If we divide both sides by cos c, assuming cos c not equal to 0, we get tan of c equal to 1. That is, if tan of c were equal to 1, then we get f dash c equal to 0, and that happens for c equal to pi by 4, etc., etc. Of course, pi by 4 suffices our work. Pi by 4 is greater than 0, less than pi by 2, and f dash of pi by 4 equal to 0. So we got a constant c such that f dash of c equal to 0, and that constant lie between 0 and pi by 2. So we did verify Rolle's theorem for the function fx equal to sin x plus cos x. We first show that it is applicable, and once it applicable, we produced a constant that Rolle's theorem guarantees us, and that constant turned out to be c equal to pi by 4.